All right, everybody, welcome to lesson 113. So this lesson has two parts, the first of which is adding and subtracting mixed measures, and the second is multiplying by powers of 10. So let's just jump right into it. So measurements that include more than one unit of measure are mixed measures. So that's like saying feet and inches together, hours and minutes, meters and centimeters, I suppose, although you could convert those pretty easily. And you see that a lot when you say something is like 3.5 feet by 4.5 feet. Okay, that would be feet and inches. If I said it took me 6 hours and 20 minutes to walk to Walmart and then 7 hours to walk home, how long was that? Something like that, which was pretty ridiculous example. But so we're going to look at adding those together. And there's not really much to it besides getting right into the examples. So let's look at example 1. So if you're in your book, it's on page 529. And of course, I mean 592. Can you believe 592? That's so many pages. The hike from the trailhead to the waterfall took 1 hour and 50 minutes. The return hike took 1 hour and 40 minutes. So maybe you guys stopped to see as many things. It was just a faster walk, walked downhill. Altogether, how many hours and minutes was the hike? So what we want to do is line these up vertically, much like when we did decimal numbers, and we're going to add the columns separately. So first we'll add the minutes. So 50 minutes plus 40 minutes is 90 minutes. And then we'll add the hour column. So 1 hour plus 1 hour is 2 hours. Now, the thing that you have to do here, which you're familiar with when you add mixed numbers, is we have 90 minutes here, and 90 minutes is greater than an hour. So what we want to do is break that down into how many hours and minutes that is. So remember, there are 60 minutes in an hour, so 90 minutes would be 1 hour and 30 minutes. Okay, so we're going to add that value to the hour value we already have, and we would find that it was 3 hours and 30 minutes. Right, it's a nice hike. 3 hours and 30 minutes. All right, let's see. I can't remember. All right, so it looks like I have to do the second example on this page as well. And that's fine. To measure his vertical leap, Tyrone first reaches as high as he can against a wall, and he reaches 6 feet and 9 inches. Then he put chalk on his fingertips, and jumping as high as he can, he slaps the wall. The top of the chalk mark is 8 feet and 7 inches. So how high off the ground did Tyrone leap? So what we're going to do is we're going to take that greater measure, the 8 feet and 7 inches, and we're going to subtract his sort of like base height that he can reach. So we're going to subtract 6 feet 9 inches. Okay, so once again, we're going to work with our column on the right first, 7 inches minus 9 inches. Right away, you can tell we can't do 7 minus 9. So what we'll do is we'll borrow from the feet column. So we're going to take 1 foot away, and we're going to add it to the inch column. So what we're going to do is we're going to add 12 inches, because remember, 12 inches equals a foot. Okay, so now we can do our subtraction appropriately. 19 inches minus 9 inches is 10 inches. 7 feet minus 6 feet is 1 foot. So he could jump 1 foot in 10 inches. Not fantastic, but you know, maybe he's training. Okay, so that's basically what you do in this first part of the lesson, adding and subtracting mixed measures. So line your things up vertically, borrow as you need, or like in this first example, break it down into the different base measures. Say, for instance, we were adding, let's do one quickly, 6 feet 3 inches plus 2 feet 11 inches. Okay, so we get 14 inches and we get 8 feet, but 14 inches is greater than 12, so we'd want to break that down into 1 foot and 2 inches. Okay, add that to our original and we would get 9 feet and 2 inches. Okay, that's the idea here. So it's really nothing new to you, but maybe you'll see some new representations of that. Okay, part 2. What we're going to do is add and subtract multiply by powers of 10. So I wrote out this little fact for you that might be worth writing down. Multiplying by powers of 10 doesn't change the digits, so the actual numbers you see will remain the same, but it changes their place value by moving the decimal the number of places shown by the exponent. Okay, so that fact is really good to know when you're multiplying by powers of 10. You're not really changing the numbers you see, but their value will change. So in this case, we have 1.2 times 10 to the power of 3. 1.2 times 10 to the power of 3, or 1 and 2 tenths times 10 cubed, sorry. So that means we're going to take 1.2, and because we're multiplying, we're moving our decimal to the right. And look, our exponent is 3, so we're moving our decimal to the right 3 spaces. So 1, 2, 3. You'll fill in those little blank spaces with zeros, so it equals 1200. You'll see the digits 1 and 2 didn't change, they just became different place values. So instead of 1.2, now we have 1200. Okay, let's see if I did anything on this page. I just got to remember. Okay, beautiful. Our next example is write 6.2 times 10 to the power of 2 in standard notation. So standard notation is just how you're used to seeing numbers. This right here, if you'll recall, is called scientific notation. So 6.2, multiplying means we're going to move our decimal to the right. And because our exponent is 2, we're going to move it to the right 2 places. So 1, 2. Fill in that blank space with a 0, and we get 620. All right, 620. It's as easy as that. Now the next one is a little harder. It says write 1/2 billion in standard notation. So 1/2 billion in standard notation. So first of all, let's think of 1/2 as a decimal, and we know that 1/2 as a decimal is 0.5 or 5 tenths. And so we're going to do 1/2 times a billion to just sort of visualize what we're doing here. So what is half of a billion? Half of a billion is 500 million. So make sure you understand your place value. So this would be like 110 ones, thousands, and millions, okay? So you'll have to really make sure that your understanding of place value is correct here. One other example, maybe we would do a quarter thousand. That's kind of silly. But what's a quarter of 1,000? It's 250. See, that was kind of a weird example. A quarter billion makes more sense. A quarter of a billion, and if you want to do that multiplication, if that helps you, a quarter of a billion is 250 million. Okay, so if you get stuck on ones like this where they're giving you fractions of a certain number, just write that fraction out as a decimal and then multiply by how you'd write that number. So this one would have been, you could write 0.25 times 1,000, or 1/4 times 1,000. Here, let's say that 1/4 times 1 billion. So that's millions, thousands, ones. All right, that's really it. That's the lesson. Very straightforward and simple, which is great because it's Friday for you. So I hope this lesson was easy. Don't forget to go back to Google Classroom and fill out the practice set portion of this. And as always, let me know if you have any questions. Man, that felt fast. I feel like that took only 5 minutes. So if you had any questions, if I went too quickly, please let me know. And yeah, I look forward to talking to you guys.